Today's lesson is over learning target 5, which states I can solve for a single variable in a literal equation. Okay, so the first thing we need to be able to do is define what a literal equation is. So a literal equation is an equation which consists primarily of letters. Okay, so an example of this would be like A times D plus C divided by F is equal to W. Okay, now here notice no numbers but same operations as what you've dealt with before in any of the other equations that we've solved with or solved for. But here, to be able to solve, they will tell you which variable to solve for. So like for an example, I could say that we want to solve for D. Okay, and so then I would try to do steps that would allow D to get by itself. So I could multiply both sides by F, and then from there I would subtract C and divide by A. Now, hopefully you notice that there are no other numbers, so you're not going to be putting, like, you're not going to know what these values are. You're not going to like figure out an exact number answer to these, but you want to solve or get a variable by itself by using the same like operations or properties, like adding the same thing to both sides, multiplying the same thing to both sides, dividing, or subtraction, like all those different things to be able to do this. Okay, so the goal here is to get the indicated variable by itself. Okay, and we're going to use those solving techniques in order to do this. So number one, we have 4m minus 3n equals 8. And here it says you want to solve for m. Okay, so I'm going to try to get that by itself. So now here you do have some numbers, and so there'll be some values that you can kind of see, but you're still not going to have a one number answer like we usually have. Okay, so if I'm trying to isolate m or get m by itself, then I need to undo the things that are being done to it. Now, if this doesn't make sense to you quite like right off the bat, compare it to something you've already done before. Okay, so let's say I have 4m minus 6 equals 8. Okay, this is an equation that you've done before where I would add 6 to both sides, right? Because I see the subtraction, I'm adding. Okay, they undo each other, they cancel each other out. So 4m is left on the left side. 8 plus 6, because they are numbers, I can add them, gets me 14. And then I would divide both sides by 4, right? Because 4 is being multiplied to m. Okay, so this is where recognizing what operations are happening and then undoing them comes in super handy, because it doesn't matter what they look like. If they are subtracting to something that you want to get by itself, you undo it with addition. If it's multiplying to something that is like you're trying to get by itself, you undo it with division. So same idea here. So for this one, I see that negative or 3n is being subtracted from 4m. So I want to undo that by adding 3n to both sides. Just like we did with the 6. Okay, so that leaves me with 4m on the left. Now, I don't know what 8 plus 3n is, okay? And you're not going to know. These are not like terms. So the big idea is that I can't put those together. I cannot make 11n. It's not the same, okay? So because it's just like addition, okay, it's kind of like this. 6 plus 3 is not the only way of writing this. I can write it vertically, or I could write it horizontally. And I say the same thing, right? That's the same thing we're going to do here with the 8 plus 3n. I'm just going to rewrite it horizontally. I can't actually add 8 plus 3n to make one number, but I'm going to write them because they are connected by that addition. Okay? And then the next part, I want to undo the multiplication of 4 with division. 4 can go into 8, but it doesn't go into 3. So then I'm going to kind of leave this as 8 plus 3n divided by 4. Okay? And that's my answer. Nothing more, no calculators needed for this, really, unless there are some numbers that you have to deal with. But pretty much you're going to have mostly letters, and it'll actually be quite easy if you know and understand all your solving techniques. Okay? That is the key here. That is what we've been practicing and working on. And so up to this point, it's all been practiced to this. This is like the ultimate being able to solve kind of thought process. Okay? If you can solve these, you can solve anything. Okay? Because this is as abstract of a thought process as anything. Okay, for the next part, number 2, I want to be able to get t by itself. So it has 28 equals t times r plus 4. Okay, now this one's interesting because your first thought would be to multiply t through to the parentheses. But I don't want to get, I want to get t by itself, so multiplying through, making it r times t plus 4 times t is not good for me, okay? Because now you've created 2 t's that you can't, it's going to be harder to go back. So just leaving it is better. So this is like saying, well, r plus 4 is all multiplying to the t, right? There's a multiplication sign in there, in between the t and the parentheses. So I would undo this by division. So I divide both sides by r plus 4. Okay? So so you have 2 terms, r plus 4, and you're dividing it by the same thing. That's just like saying 2 divided by 2. They cancel each other out, which is very nice. So then on the right side, you're left with t. On the left side, I don't know what 28 divided by r plus 4 is, so I would leave it as r plus 4. And then that's my answer. I got t by itself, right? Okay. All right, number 3 here, you want to get k by itself. For k minus 2 divided by 5 equals 11 plus j. Okay, so this one has more numbers attached to it. So the first thing I would do is, because you have a division of 5 there, I would multiply everything by 5. And that means everything on the right side I multiply by 5 too. Okay, so on the left, the 5's actually cancel each other out, leaving you with k minus 2. Now you can distribute here if you would like. Okay, so that gets me 5 times 11, which is 55. And then 5 times j, which is 5j. Okay, and then the last step for this one is adding the 2 over. Now for this one, you do have some like terms of 55 plus 2, which is not out of the realm of possibilities. You can get like terms with these. It's just not everything's like terms. Okay, so then I get k equals, and then 55 plus 2 is 57, plus 5j, and then k is by itself. So that's my answer. Okay, I'm going to stop there and start the next video with number 4. Okay, have fun.